Hello Math 126 students, now I'm going to work through page 2 of the 2024 exam. Again, my goal is to first work through it as if I'm a student and then circle back and talk about where you would have seen this in your studying and how to reflect. So the first question says, determine whether each statement is true or false in 3D. Two different lines parallel to a given plane must be parallel. So your thought should be, can I prove it? Or can I find a counterexample? So for those of you that are struggling with true-false, that's your organized way to think about it. It might help to draw a picture. You should generally try to draw a picture where it's false. I find people tend to try to draw a picture where it's true. But try to draw a picture where it's false. That's the counterexample idea. So we need to draw two different lines that are parallel to a given plane. And so this would have been the picture. I always draw the same plane. I would have had a line parallel to the plane. That means that it doesn't ever get closer. And so then your job is to try to draw another line that's parallel to the plane that's not parallel to that line. And that's actually pretty easy to draw. You could draw it almost anywhere. You could draw it coming this way, where these are all the same distance. It was kind of bad how I drew it. But the point is they can be skew. You have another line like this that goes underneath it and is a little closer. So just because two lines are parallel to the same plane does not mean they're parallel to each other. So I hope that's sort of helpful just in general when you're dealing with true-false. I find that what people tend to do is they draw two pictures that make it true. They have a line, they have another line. But that's not what it says. It doesn't say the lines have to be parallel. It just says they have to be parallel to the plane. Parallel to the plane. Okay, so that's got to be false. This also is directly from the homework. I took both of these word for word directly from a homework question. Okay, other thing. Two different planes orthogonal to a given line. So now I have a given line. So this is given. This is given. And then I want to draw two planes that are perpendicular to it. Okay, so here's a plane that's perpendicular to it. And that means, we like this scenario, that means the normal vector is parallel to the direction vector for the line. But now I have to draw another plane that's perpendicular to it. Now if you think about that, I don't have any choice of how to draw this. I have to draw it perpendicular because it says perpendicular. That means these two things have to be parallel. So I tried to disprove it, but I couldn't. This is true. But you can prove it to yourself because these two things have to be parallel, and these two have to be parallel, so those two have to be parallel. That's it. But anyways, so there was a little bit of a challenge there, but that was directly from the homework. You could have put on your note sheet. Consider the line L1 given by this. A second line is perpendicular to this plane and intersects this. Okay, this is one of the situations we really like. If there is a plane, and this would be my very first thought. Well, my first thought would be we are trying to find the equations for a line. So the very first thing you should have written was this. This, plus. We normally put a T, but I'm going to put a U. The reason I'm putting a U is because the T is already in use by the other line. So your job was to find a point and a direction vector for your line. That should have been immediate. There were people that their final answer wasn't even an equation for a line, which I don't understand. That's a preventable mistake. Okay, so I'm going to draw this line perpendicular to this plane. Why am I drawing it perpendicular to the plane? Because it says that. And I already have this vector, 3, -1, 5. If you look at my old test, you know this was coming. I almost always have this question because it forces you to show your understanding that you can use the same vector right here. Next, so the other question in there was, it also goes through the z-intercept of this plane. So you had a little bit of just general 3D knowledge to throw in here. How do you find the z-intercept of this? How do you find when this plane hits the z-axis. Well, when it hits the z-axis, x and y have to be 0. So you're just going to put in a 0 here. You put in a 0 here, divide by 5, and you get z has to be 6. So I told you the point. So that threw some people off. But I gave a point, and I gave the direction. That was immediate. So that confused more people than I thought. A lot of people got this right, but anyways. And then it says find the intersection of the two lines. Now that part seemed to really get a few people, but you should be combining these two. We should have 3u. We did a lot of this in the homework and in class. We should have had negative u equals 4 plus 2t. We should have 6 plus 5u equals 1 minus 5t. And then you combine and solve. To me, maybe the easiest way to combine, I don't know what the easiest is. It looks like there's several different ways that are fast to combine. Just pick one. I don't know, for example, you would get t equals 3u minus 9, substitute. So we're going to have negative u. This is probably not the best way, but it's working. 3u minus 9. So we have negative u. And I find, okay, then we keep solving. I think this is negative 7. You get u is 2. Then once you have u is 2, you have t is, this might have been the part that slowed people up, negative 3. But then you're there. Last thing you need to do is check. Okay, when this is 2, this is negative 3. So we have 16 equals 16. Hooray! And then you put your point in, so then you get the equation of the line is what I asked for here. X is equal to 3u, y is equal to negative u, z is equal to 6 plus 5u. And the point we get, so if we can plug the u or the t in, we're going to get 6, negative 2, 16. Okay, and lastly, find the equation of the plane that passes through this point and contains the line of intersection of these two planes. Now this is on all my old tests. And your very first job is to find 2 points. So your job was to combine. So let's combine these two. If it was me, I probably would add them together. I don't know, let's see. 3x plus 6z equals 12. I would divide everything by 3. Okay, after you combine, you then need a couple points. I probably would use x is 0 when x is 0. This is 4 here. When x is 0, you get z has to be 2. And then you get when this is 0 and this is 2, your y has to be negative 1. And then for b, when z is 0, you get x has to be 4, 4 and 0, so y has to be 1. Then you should have a plan forward. You already have this other point, 3, 2, 1. And so you should just be computing 2 vectors, taking their cross product. So AB would be 4, 2, negative 2. AC would be 3, 3, negative 1. Cross product. Negative 2 minus negative 6. That's going to be 4. Negative 4 minus negative 6, that's going to be negative 2 when we're all done. And 12 minus 6 is going to be 6. So you're going to get 4, negative 2, 6. So then you have 4. You can use any of the points. I think a lot of people use the original point, which is fine. Negative 2. Y minus 2 plus 6 z minus 1. So that's it. I imagine that page took people the longest. Probably a full 10 minutes, maybe 12 minutes. But it was still doable in that time. This is about preparation. Let's briefly check the solutions. So each of the true false was 1. Finding the line, that should have been immediate. So if you look at your exam and you do not immediately have, writing down the form of a line, that's troublesome. Like if you didn't write a line here, right? So that's the thing. Many ways to do this problem, all are correct. So the comment now I have in terms of reviewing, just a comment about lines and planes. That's about lines. So what you have to be doing as you're reviewing is comparing what you studied and what you saw on the test and how you encountered the homework, because you want that to adjust moving forward. So anyways, one comment is right here. So the two things I copied, 2 lines perpendicular, 2 lines parallel to a given plane are parallel. And then 2 planes perpendicular to a given line are these 2 things I picked. This one and this one I put on our exam. So the comment I would have is, when you were doing that on the homework, did you understand it? You might say, well, there was a lot of questions. I was just trying to get through it. But that's a place you can practice. Now, in terms of finding contains a point in the intersection of 2 lines, here's this. I stole this directly from the homework. In fact, I used the exact same setup from the homework. I took one of the randomized numbers. Find the equation of the plane that passes through this point and contains the line of intersection. That's the same question. I copied the words from the homework. So I do that on purpose, not to be mean, but because I'm like, well, you've seen the homework, and so that's something we've all seen, and it's fair wording. So I say that to sort of tell you that's what you got to be thinking about as you're doing the homework. Again, always you have to study the most recent exams. If you studied the most recent exams, you would have seen this, which is very similar. In fact, in my exam this quarter looked very similar to the most recent one in the archive. And then I said, consider the line that contains this point and is orthogonal to the plane. That's the same question almost to our question. I ask a slightly different intersection after that, but if you knew how to do this question, you would have immediately found that line. And this section says, find the equation of the plane that passes through the point and contains the line of intersection. It's the same question. So I always say that because people say time was a factor or something. So one way you can fight that time is by working through all the exams and asking yourself, can I do that in 10 minutes? Can I do this in 10 minutes? And I really took this question, I thought I was giving too much away, and asked almost the identical question on exam 2 of our exam. So if any of those parts of that question, the point is not to criticize, but if any part of the test on you were studying and you got right here and you're like, I don't know what to do, that's part of preparation. You can fight that for the next exam by working through these couple of exams here in detail and making sure you know how to do them in one step. Okay, I hope that sort of helps.